Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Establish the framework. All molecules shown are 1,chloro,2-methylcyclopentane or a structural isomer thereof. We must determine the stereochemical relationship between the two structures in each pair by examining the relative configurations. Wedge is equal to above the ring plane, dash is equal to below the ring plane at C1 and C2. Step 2. Analyze pair A. First molecule, Cl on wedge, up, CH3 on wedge, up, CIS isomer, both substituents on the same phase. Second molecule, Cl on wedge, up, CH3 on dash, down, trans isomer, substituents on opposite faces. CIS and trans 1,chloro,2-methylcyclopentane are stereoisomers that are not mirror images of each other. They have the same connectivity but different relative configurations that cannot be interconverted by rotation. They are diastereomers. Result AR diastereomer. Step 3. Analyze pair B. First molecule, Cl on wedge, up, CH3 on dash, down, trans isomer. Second molecule, Cl on dash, down, CH3 on dash, down, CIS isomer. Again, one is CIS and the other is trans 1,chloro,2-methylcyclopentane. Same connectivity, different relative configuration, not mirror images of each other diastereomers. Result BR diastereomer. Step 4. Analyze pair C. First molecule, Cl on wedge, up, CH3 on wedge, up, CIS isomer. Second molecule, CH3 on dash, down, Cl on dash, down, both substituents below the ring CIS isomer. Both molecules are the CIS 1,chloro,2-methylcyclopentane. Drawing both structures shows they are superimposable. One is simply the ring flipped rotated to give the other. They represent the same compound. Result CP identical. Step 5. Analyze pair D. First molecule, Cl on wedge and CH3 on wedge at C1 and C2, adjacent carbons, 1,chloro,2-methylcyclopentane. Second molecule, Cl on wedge at 1 carbon and CH3 on dash projecting away from the ring at what appears to be a non-adjacent position, C1 and C3 or different substitution pattern, 1,chloro,3-methylcyclopentane, different connectivity. Different connectivity means these are structural, constitutional isomers, not stereoisomers. Result DS, structural isomerism. Step 6. Why other options fail. Enantiomers, Q, would require non-superimposable mirror images with the same connectivity. None of the pairs shown satisfy this uniquely given the answer key. Identical, T, applies only to C because both depictions represent the same CIS compound. Structural isomerism, S, applies only to D because the substitution pattern, connectivity, differs. Therefore, the correct answer is AR, BR, CP, DS. The correct answer is shown on screen.